Good morning, everyone, and welcome to today's lecture. We are in work, power, energy, and we were seeing in the last class the work done by a variable force. We had seen how to find out the work done when the graph is given, and we are expecting a question on graph, whether it is coming from this chapter or coming from other chapter. The concept remains same. You have to find the area. This could be a velocity time graph. You can find the displacement from that velocity time graph, or this could be force displacement graph. You can find out the work done from that graph, or this could be force time graph. You can find out the impulse or change in momentum from that graph. So I hope everyone remembers this. Yes or no? Can I have raised hand that everyone understands this? We have done enough problems in this category that we can cover. Remember, these type of graphs are going to come in the chapters which are ahead as well. So we will be doing them again probably. But remember how we have found out the area, simple things. Let us now move on to the next topic, and the next topic is energy. The name of this chapter is work, power, and energy. We are done with work. Now we will move ahead with the next heading, and the next heading is energy. The heading is kinetic energy here, but we are going to first understand what is energy. What do you mean by energy? Anyone? Anyone has any idea what do you mean by energy? Whenever you think about the word energy, whether you use it in normal language, I have enough energy, you don't have energy. What do you mean by the term energy? Anyone? Any idea what is energy? Hmm? Ever heard this term energy? Anyone? Okay. Energy is the capacity to do work. I hope you remember it now. Capacity to do work is known as energy. When something has energy, it has a capacity that it can do work. Even if you use this term in your normal language, energy always means your capacity to do work. So remember this. This is the same term that we have used in your lower standards, 7th standard, 8th standard, 9th standard. Energy is the capacity to do work. It still remains the same, nothing new addition. The only thing you have to understand is what are its dimension and what are its SI unit. So remember, the dimension of energy is ml square T minus 2. Remember this dimension, don't forget it. The dimension of this is ml square T minus 2, and the dimension of energy is same as the dimension of work, or something which is going to come in the next chapter or the next to next chapter, torque. So energy is the capacity to do work. It has the same dimension as work. The SI unit of energy is joule, and you can also write this joule as Newton meter. Joule can also be written as Newton meter. It is same as work done. The CGS unit of this work is known as ergs. That's the CGS unit of energy. It is known as ergs. You must also remember the relation between various units of work and energy, because they can come as small questions in your exam. So you must remember what is the relation between joules and ergs. Anyone knows the relation between joules and ergs? Joules and ergs. Then there is one more unit which is used, which is electron volts. So here is a table that you can see on your screens. This tells us the relation between different units of energy or different unit of work. Remember these because you might be using it. You might be using it in some questions. So The first thing is 1 joule is 10 raised to the power 7 erg. Joule is the SI unit. Erg is the CGS unit. Then there is one more unit, 1 electron volt. This will come in the chapter on electricity or modern physics. So 1 electron volt is 1.6 into 10 raised to the power minus 19 joule. 1 kilowatt hour is 3.6 into 10 raised to the power 6 joule. 1 calorie is 3.18 joule. This unit will come in your chapter on heat or thermodynamics. So you must remember all these forms, all these conversions of energy from one unit to the other unit. I'll give you 1 minute to note it down. Once you are done, please let me know. Let me know once you have noted down, beta.
Done, sir.
Okay, good. Now, these conversions you might have to use in different cases. Anyways, now this energy, you might have heard different types of energy. So this energy can be of different types. I'll show you a table. If you want, you can note it down. Else you can just all these types of energies. You already know. You can just go through this. Um, what are the energies that might have heard about? You might have heard about kinetic energy and potential energy. Together we call it the mechanical energy of a body. Mechanical energy, then you have chemical energy, electrical energy, sound, nuclear, heat, light, magnetic. We'll be covering almost all types of energies in our course. Chemical energy probably you will be covering in chemistry. Sound energy, heat, nuclear, light, magnetic energy, everything will be covered in the course of 2 years. Basically, in this chapter, what type of energy we are concerned about is the first type, and the first type is mechanical energy, which consists of two parts, the kinetic energy and potential energy. So we will be concentrating on the first type of energy. The other type of energy would be coming in other chapters. When they come, then we will be concerned about them. Okay, so right now we will only be concerned by mechanical energy, but since we have seen how we can convert from one unit to the other unit, there is a small question that comes on this category. So please help me in solving this. This is a question. Now remember, you must have heard about something about energy. Energy cannot be created, energy cannot be destroyed. We will be writing that after this. uh, Energy can only be converted from one form to another. So wherever you are converting energy from one form to another. For example, right now I'm speaking, I'm creating sound energy. This sound energy comes because I eat, I get energy from the food that I eat. Every packet, if you buy some pre-made food, a packet of biscuit, a packet of bread, or anything, it has written how much energy it has inside it. It's normally written in terms of kilocalories. That is the question. I mean, when you eat that food, you will get that much amount of energy in your body. This is the question that is based on it, so that you understand how energy gets converted from one form to another. It is in the form of chemical energy in the food. And once you eat it, it gets converted into energy in your body. You call it internal energy. Then with this energy, you can do work. So you convert it from one form to another. This is a simple question. An ice cream has a marked value of 700 kilocalorie. How many kilowatts of energy will it deliver to body? So how much energy you will get in kilowatt hour when you eat it? So it's basically a question based on conversion. I'll give you a minute to get me the answer for this one. So anyone got the answer for this one? So how are we supposed to solve this? You have to convert kilocalorie in kilowatt hour. So how will you convert kilocalorie into kilowatt hour? Yes. So you can convert first of all 700 kilocalorie into joules. How you can convert it into joules? So 700 multiplied by 1000, that is 700 kilocalories. 1 calorie has 4.2 joules of energy. So this is divided by 4.2. And then you know the conversion between kilowatt hour and joules. 1 kilowatt hour is 3.6 into 10 raised to the power 6. I had given you the number. So this many joules are there. If you divide it by 3.6 into 10 raised to the power 6, whatever you get as the answer would be the energy in kilowatt hour. And I think you are getting somewhere around 0.81. So 0.81 kilowatt hour is your final answer. I repeat, how did you convert it? You first convert kilocalories into joules by multiplying it by 4.2. Then you convert joules into kilowatt hour by dividing it by 3.6 into 10 raised to the power 6. Whatever you have is your energy in kilowatt hour. We understand this, everyone? It's just converting from one unit to the other unit. Shall we move ahead? Yes? Have you noted it down, everyone? Okay, great. That takes us to the first type of energy that we are going to deal with. And the first type of energy that we are going to deal with is kinetic energy. And this is the energy that we see in our everyday life. Kinetic energy. I will denote this kinetic energy by the letter K. K, wherever you write K, that will means the kinetic energy. Now, what do you mean by kinetic energy? Anyone heard this term kinetic energy? Can anyone tell me what do you mean by kinetic energy? Yes?
Hello.
Yes, beta? You're saying something I could not get you? No? Anyone else? Kinetic energy? Heard this term? Okay. Kinetic energy is the energy possessed by a body. Energy possessed by a body. Can anyone repeat? Can anyone complete the sentence? Energy possessed by a body? Okay. By virtue of its motion, when a body is moving, the energy it has is known as kinetic energy. Energy possessed by a body by virtue of its motion is known as kinetic energy. And what is the formula of kinetic energy? Kinetic energy K of any body will be equal to half mv square. Where what is m? M is the mass of the body, and v, I will call it as the speed of the body. V, I will call it as the speed of the body. Books will tell you that v is velocity, but here I am using v as speed of the body. Why I am using v as the speed of the body? Because kinetic energy only changes when you change the speed of the body. When I say speed, I mean the magnitude of velocity. That is why I have used v as the speed of the body, because sometimes if a body is in circular motion, its velocity may keep on changing in direction, but the magnitude does not change. In that case, your kinetic energy will not change, and therefore, instead of calling it as v, I prefer calling it as speed of the body, so that as soon as you understand, okay, it is half mv speed square, only when you change the speed, then only your kinetic energy will change. What type of what type of quantity is kinetic energy? It's energy, so it will be a scalar quantity. This SI unit again will be joules. It is kinetic energy, energy possessed by the body by virtue of its motion. It is half mv square. What you need to remember it, kinetic energy K depends on, and write it very clearly, the magnitude of velocity kinetic energy depends on the magnitude of velocity. Therefore, I am using the word speed for it. and not velocity. Kinetic energy depends on the magnitude of velocity. It does not depend on the direction of velocity. Therefore, instead of calling half mv square v as velocity, I am calling v as speed. Now, just to give you an example, if a body, oops, what I'm doing. If a body is moving in a circular path, in uniform circular motion, if it is moving like this, here the velocity is v like this. At this point, the velocity is v like this. At this point, the velocity is v like this. At this point, the velocity is v like this. As you can see, in this case, velocity is changing. Velocity of the body is changing because it is changing in direction. The direction of velocity is changing, but speed is constant. Speed is the magnitude of velocity. And therefore, kinetic energy is constant. So whenever you think about kinetic energy, half mv square, always understand, always think that v is not the velocity, but v is the speed of the body that will help us in overcoming any confusion about if velocity changes, does the kinetic energy change? Well, kinetic energy may change if the magnitude is changing. Kinetic energy will not change if only direction is changing. Do we understand this? Can I have confirmation that we understand this? Boys, girls, we understand this? Great. Okay. One more thing that you must remember about kinetic energy. One more thing that you must remember about kinetic energy is that since it depends on the speed, and speed depends on your reference frame. Right now, I'm sitting with respect to Earth. I am at rest. So my speed or my velocity with respect to Earth is zero. Therefore, my kinetic energy would be zero. But if someone watches me from outer space, I am moving along with Earth. So I'm in motion with Earth. So if someone watches me from outer space, he will see me moving. And then he will see, okay, you also have a kinetic energy because you are moving. Therefore, kinetic energy depends on the frame of reference. So please remember this. All these small things can come as question in your exam. So please remember this. Kinetic energy depends on frame of reference. Kinetic energy depends on your frame of reference. Okay, kinetic energy depends on frame of reference. It's a very important aspect. Please remember it. Have you noted it down, everyone? Okay, now we come to the next point, and this is a very important aspect of your NEET exam, because every time when a question comes on work, power, and energy, it comes from this particular section, and it is almost certain that you might have a question based on this in this year's exam as well. So you can write the heading relation between K. What is K? What is K?
Kinetic energies.
And P. What is P?
Potential energy.
P is momentum. Remember momentum? Momentum? Momentum, mass into velocity, momentum. Remember, amount of motion in a body, momentum. Rate of change of momentum is force. Remember momentum? So this is a very important relation between kinetic energy and the momentum of a particle. Now remember, kinetic energy of a particle is half mv square and the momentum of the particle is m into v. Both are functions of m and v. Both are functions of m and v. So we can write simple relation between them, and most of the question in this chapter comes from this relation. So just write these relations, bacha. Kinetic energy is half mv square. M into v is momentum. So you can write it as half into momentum into v, or you can write v as p by m. So you can write it as p square by 2m. So you can write kinetic energy as p square by 2m. We understand this? Yes or no? Simple relation from here and there. Since you can write kinetic energy as p square by 2m, now I can write it in the reverse order. Momentum p will be 2 times k by v, or I can write it as 2 times m into k ka under root. These are 2 or 3 very important relationships coming from the same p is equal to mv and k is equal to half mv square. More often or not, you are supposed to get a question from this part. So this becomes a very, very important part for your NEET preparation. Have we noted it down, beta? Everyone? Okay. So now, as you can see, there is always a question coming around the corner when you're talking about momentum and kinetic energy. And this is the question. As you can see, it has been repeated multiple number of times. And we expect that it can be repeated once again. If the momentum of a body increase by 100%, then the percentage change or percentage increase in your kinetic energy would be how much? I'll give you 1 minute to solve it. I hope all of you are trying it and all of you will give me an answer. Anyone got any answer? I hope everyone is trying. Boys, are we trying? Or are we chit-chatting? Is there anyone in the class that I can talk to?
Option A, sir.
Option A, 150%. Answer is 300%. But okay, well tried. How did you get it? Chalo, let us solve it together and let us see how we are supposed to do it. Please watch the steps very carefully. You have to find the percentage increase in kinetic energy. So let us start one by one. I know the kinetic energy is P square divided by 2m. Do we remember this formula? P square by 2m, everyone? Just now I have given you this formula, P square by 2m. Remember, the mass of the body has not changed. The only thing that would have changed would be the velocity, and therefore the momentum changes, and therefore the kinetic energy changes. If I call the first kinetic energy of body as K1, so K1 will be P1 square by 2m, the first kinetic energy, initial kinetic energy. Then I have the final kinetic energy K2. K2 will be P2 square divided by 2m. We understand this? So these are the two kinetic energies. P1 and P2 are the initial and the final momentum. I have to find out how much is the value of K2. How I am going to do it? I can find out the ratio. Final kinetic energy K2 divided by initial kinetic energy K1. I will divide these two. M and M will get cancelled. 2 and 2 will get cancelled. I will have P2 divided by P1 whole square. Do we understand this? When I divide, I will have P2 divided by P1 whole square. Then I look at what is given in the question, beta. Momentum of the body has increased by 100%. Momentum of the particle has increased by 100%. That means if the initial momentum is P, if I call the initial momentum as P, if I call this initial momentum P1 as P, if I call this initial momentum P1 as P, can anyone tell me what would be my final momentum? Momentum has increased by 100%. Initial momentum, I am calling it as P. Can you tell me what would be the final momentum? Momentum has increased by 100%. Initial momentum is P. What would be the final momentum? Something increases by 100%. Initially it is P. What will be the final value? No one has any idea? Something increases by 100%. If your marks in the exam is 50, and if your mark increased by 100%, what will be the final marks? You got 50. And it looks like the way boys are sitting, they might not even get 50. If your present marks are 50, and your marks increase by 100%, what will be your final marks? So 100
plus P.
How much?
100 plus P.
100% beta. It is 100%. Something increases by 100% means if your initial value is something, the final value increases by the same amount. So if initial value is P, the final value becomes 2P. So remember this. The final value becomes 2P. Okay. Do we understand this? Now, the initial value of kinetic energy, the initial value of potential energy, momentum is P. The final value of momentum is 2P. Can you now solve the question and give me the answer? I'll give you 1 minute. Yes. Do we have an answer? So, the initial momentum is P. The final momentum is 2 times of P. So I can get from that K2 by K1 will be equal to 2P divided by P squared. 2P divided by P and P will get cancelled. So I will have K2 by K1 will be equal to 4. I will get K2 by K1 is equal to 4. So I can write K2 becomes 4 times K1. Your final kinetic energy will be 4 times of initial kinetic energy. Your final kinetic energy will be 4 times of initial kinetic energy. Now the question is, how many percentage it has increased? What percentage you have increased? Your final kinetic energy becomes 4 times its original value. By how much percentage it has increased? By how much percentage it has increased? So you can write it as K2 will be equal to initial kinetic energy is K1 plus 3 times of K1. The initial kinetic energy is K1 and now it becomes 4 times K1. That means you will have to add 3K more. Therefore, it means that the percentage change is 300%. Do we understand this, everyone? Boys, do we understand this? Okay, please note it down. So I hope everyone has noted this question down. Kinetic energy, the final kinetic energy is 4 times of K1. So I can write it as K1 plus 3 times of K1. That means it has increased by 3 times. If it has increased by 3 times, the percentage increase becomes 300%. If it increases 1 times, the percentage increase is 100%. If it increases 2 times, the percentage increase is 200%. If it increases 3 times, percentage increase is 300%. Do we understand this, everyone, in the class? Boys, I have an all-seeing eye and I look for people who are on date. So please be attentive in the class. We are on a class and not in a garden. And this is not the time for you to date. If the police catches you on a date, you will have a very hard time. Forget about becoming doctors. You will not even get a panwala job once you have a police record. Okay, let us move on. Great. Okay, let me give you one question on this. I've been working so hard to, to get you questions from everywhere so that you can attempt all types of questions. But what I feel is some someone who's not interested, he spoils the entire class. Now, this is the question, and I think the question that we did was the exact opposite of it. So remember, if you work hard enough, the same question that you have done in the class will come in the examination hall. Your dating expertise will not help you in the class. Only doing questions in the class will help you. Please remember it. This is the question
Option
that we
C,
are
sir.
giving. Yes, beta?
Option C.
See, as soon as the date got over, we are in the class and we got the answer. Option C, it is very good. See, just pay attention. This is the exact reverse of the first question. Yes or no? In the first question, momentum of a particle increased by 100%. We saw that its kinetic energy increases by 300%. This question is the exact reverse of it. And this came in the year 2002. And the previous question that we did came in the year 2001. See, it was repeated from 99 till 2001. Same question came. The same question got reversed and came in the year 2002. It tells us that if you pay attention and if you do questions, beta, same question is going to get repeated. They will not even change the language of the question. That is how NEET papers are made. Do we understand this, everyone? So please pay attention in the class. Everyone understand how I got the answer 100% without even solving it? Great. Well done. Chalo, this is one category of question where they ask you how much is the change. The other category, the next category of question is this. So either you will get a question from this category, bacha, or you will get a question from this category. This one. Two bodies with kinetic energies in the ratio of 4:1 are moving with linear momentum, equal linear momentum. What is the ratio of their masses? Sometimes they will give the ratio of kinetic energy, beta. Sometimes they will give the ratio of momentum. And then they will ask you the second quantity. So I will give you this one. I will give the reverse one as well, so that you will understand the two types of question that can come. Out of these 4 or 5 questions, you will get 1 or 2 questions in your examination. Can anyone tell me the answer for this one? Two bodies with kinetic energies in the ratio of 4:1 are moving with equal linear momentum. What is the ratio of their masses? I'll give you 2 minutes to do it. Yes, anyone with any answer for this? Okay, shall I do it? Yes, I have an answer, it seems. Yes, bacha. No answers? So how are you going to do this? Let's proceed. Two bodies with kinetic energies in the ratio 4:1. So if I call the first kinetic energy, the first kinetic energy as K, the second kinetic energy should be in the ratio 4:1. So the second kinetic energy becomes 1/4K. Do we understand this? If one is K, the other one is 1/4K. They are moving with equal linear momentum. If you don't understand it in this way, what you can do is, you don't understand the ratio here, you can just write K1. K1 will be P square divided by 2m1. You can write it this way, not a problem. You might make a mistake in taking the ratios, so be safe. You can write it like this. K1 is P square by 2 times m1, because they have the equal linear momentum. I know that the linear momentum is equal. Now I can write the value of K2, the second kinetic energy. Momentum is same, remember. So it will be P square divided by 2 times m2. K2 becomes P square divided by 2 times m2. Now I can divide the two. If I divide the two, what will I get? K1 by K2. K1 by K2 will be equal to, if I divide this P square and this P square will be cancelled, and I will get this 2 and 2 will also get cancelled. I will get K1 by K2 as M2 by M1. So the ratio is reverse. K1 by K2 is M2 by M1. So if their kinetic energies are in the ratio 4:1, if the kinetic energies are in the ratio 4:1, can you now tell me what is the ratio of their masses?
1:4, sir.
1:4, and that is the correct answer. 1:4. So kinetic energy and masses are in the reverse ratio if momentum is same. Do we understand this, everyone? Boys, girls? Good. Now I'll give you one question as homework, which is similar question but asked in a different way. Here they have given the ratio of kinetic energy and they have asked you the ratio of their masses. There are three things involved here: kinetic energy, momentum, and mass. There are three things involved here. So they can give you any question in a same way. How they can give you any question in the same way? So this is a question for your practice, which I am going to give you, and I hope that you can solve this. And there is one or two more questions that we'll do. I expect that you will get one of these questions in your examination hall. Two bodies of masses. So now the ratio of masses are given, m and 4m, are moving with equal kinetic energy. So kinetic energies are given as equal beta. What is the ratio of their linear momentum? So here the ratio of masses is given, kinetic energy is equal. You have to find the ratio of their momentum. So only three things are involved: kinetic energy, momentum, and mass. And this is a pet question of your NEET. It's going to come in one way or the other. There are two or three, I can see 7 or 8 types of same question which have come almost in every year. So I'll give you this. We will do one or more questions in the next class. Take care. Have a nice day. God bless you all. Bye bye.